Alright, so in this video, I'm going to give you guys a basic idea on what quadratic equations look like. So, okay, let's start with this very simple square function y is equal to x squared. So to graph that, of course, we're going to make a table, okay? So on the left side, we have x, and on the right side, we're going to have, I'm going to use a different color. I'm going to use blue for this. X squared, okay? So for the values of x, I'm going to pick -2, -1, 0, 1, 2. Okay, so for the value of x squared, it's just the square of x. So here we're going to have 4, 1, 0, 1, 4. Correct? Okay, now we're going to graph that. Okay, so at x is equal to -2, x squared is equal to 4. So it's going to, the point is going to be right here. But x is equal to -1, x squared is going to be equal to 1, so the point is going to be right here. At 0, x squared is going to be at 0 also, and we just mirror the left side onto the right side. So our graph is going to look like that. So our graph basically is a parabola. So y is equal to x squared. The graph is a parabola. So I'd like to ask you, what's going to happen now whenever we put a coefficient to the x squared? Let's say we have a 2 here now. So we're going to put the values of 2x squared onto the table. So here we just double the x squared to get 2x squared. So 4, that becomes 8. Double of 4 is 8. Double of 1 is 2. Double of 0 is just 0. And then we just copy the values above. Okay? So we're going to graph that here. So for -2, the value is 8. So it's going to be right here. Let me pick white, because I'm going to extend the axes, the tick marks on the axes. So, okay, so at -2, the value of 2x squared is going to be at 8. So that's going to be roughly around here. Oops, I need to use green. So there we go. And at -1, the value of 2x squared is at 2. Basically double of the blue graph. At 0, it's equal to 0, and then we just mirror the left side onto the right side, and we're going to end up with this. So as you can see now, putting a coefficient before the x squared just scales the graph. Okay, so we put 2, so the graph is now double in height, as you can see. So one more. So what's going to happen now, of course, if we, let's say our coefficient, let's make the coefficient into 1/2. Let's put a 1/2 right there. What's going to happen now? So I'm going to put put another column on the table, because we want to put a table for 1/2 x squared as well. So right here, I'm going to put 1/2 x squared. Pick my red. I'm going to put here 1/2 x squared. So half of 4 is how much? 2. Half of 1 is 1/2. Half of 0 is just 0. And then here is 1/2. Also 2. Okay. So let us graph 1/2 x squared. So at -2, it is equal to 2. At -1, it's equal to 1/2. So it's right here. At 0, it's equal to 0. And then we just mirror the left side onto the right side. There we go. So this is equal to y is equal to 1/2 x squared. And this one, I forgot to put the function here. It's equal to 2x squared. Okay, so as you can see, the coefficient, the point is the coefficient just scales the function. So coefficient of x squared scales the function taller or shorter. Okay, that's the point. That's just the point that I'd like to bring to you guys. Okay? So there we go. Okay, so what do you guys think is gonna happen now if we, let's say, put a negative sign to the left of our x squared, to our old function? So, what's gonna happen now is that every value before is gonna be negative. So, here, it's gonna be negative 4, negative 1, 0. There's no negative 0, just 0. Negative 1, and then here's negative 4. So what's gonna happen now is that everything before is just gonna flip upside down. Just like this. So this is y is equal to minus x squared. So that's what it does. So that is what the negative sign does. It just flips your your original function upside down. Okay, so the example that I showed you guys before was easy. It's just y is equal to x squared. But what happens now, let's say, when we have a complete quadratic now? Let's say we have the function x squared plus 2x plus 1. And you might recognize this as the square of a binomial. Okay, so what do you see here in this function? So as you can see, this function is divided into two parts. This part is the linear part of the function. And this part is the quadratic part. Alright, so what I'm going to do now is I'm going to graph this. I'm going to graph them separately. So since the linear part is easier to graph, I'm going to graph that first, alright? So as you can see, the 2 here, that's the slope of the line. This is the slope. And the 1 is the y-intercept. Okay, so if we know that the slope is 2 and the y-intercept is 1, we're just going to start here. Just going to make a point here. The rise is equal to 2 and the run is equal to 1, so the next point should be right around here. Okay. And I'm just going to make a line. Just like that. Alright. Okay. And now we're going to graph the quadratic part. So this is y is equal to x squared. We already graphed this before. So at 2, negative 2 is right at 4. Negative 1, it's at 1. 0 is at 0. And then we just mirror the left side to the right side. So the graph is going to look like that. Just like in the previous video. Now, we're going to graph the entire function. And the easiest way to explain this is to make a table. Let's make another table again. On the left side, I'm going to put x. And for its values, let's start with minus 2, minus 1, and end at 1 and 2. Okay. Here, I'm going to put x squared. And we already know the values for these. This is 4, 1, 0, 1, 4. And here we have the linear part. I'm going to put the linear part of the quadratic equation. And that's going to be 2x plus 1. And the value for this is going to be, so 2 times negative 2 plus 1, that's equal to minus 4 plus 1, that's equal to minus 3. Right. And then minus 1 times negative 2, that's minus 2, plus 1, this is minus 1. And here, at 0, this is just going to be equal to 1. At 1, this is going to be equal to 3. And you see the trend now. Next one is going to be 5. Okay. So to get the whole function, we just add these two numbers up. But first, let me write on the top x squared plus 2x plus 1. Because this is just a sum. So 4 plus minus 3, 4 minus 3 is just This is just 1. This is going to be 1. This is going to be 0. If this is 1, 1 plus 3 is 4. And 4 plus 5 is equal to 9. Okay, so here I'm going to graph from the right now. So 2, this is going to be equal to 9. So it's right around here. Let me check. 1, 2, 3, 4, 5, 6, 7, 8. So at 1, it's equal to 4. So it's right around here. At 0, it's equal to 1. And at negative 1, it's equal to 0. And here, at negative 2, it's equal to 1 again. And you can see the trend now. It's just going to mirror the right side. Okay? Right side of the parabola, it's just going to mirror it on the left. Alright, so graph is going to look like that. Oops, let me try that again. Oh, I need to connect the dots correctly. There we go. So as you can see, what's going to happen? Whenever you have a parabola, so what we did here is we have the red parabola, and then we added to that the blue line plus this. That's equal to the green parabola. And basically what happened to the green parabola? So the green parabola is just the red parabola shifted to the left. So that is what the line does. So this line here, so this line shifts the parabola. So that's the point. That's my point exactly. When you have a line added to a parabola, it just gives you another parabola but shifted to another position. That's it.